Hello, class. I was looking at a few things that we were doing in the first couple of lessons in Chapter 5 of the pre-calculus, and what I noticed is that several students were having trouble with simplifying radical expressions. So this is nothing new. This is just a quick little review. But what you have to recall is that if you have a fraction that has a radical in the denominator, that's called an irrational number because you can't find the square root of 3. So what we have to do is rationalize the denominator. We're not worried about the numerator, just this denominator here. So to make it a rational number, we're going to multiply by a name for 1. And the name that we choose is going to be the square root of 3 divided by the square root of 3. Oops. Anyway, so when we multiply both the numerator and denominator by the same thing, that's just really multiplying by 1. 2 times the square root of 3 is equal to 2 square root of 3. You can't multiply an integer and a radical, so we're just going to leave it as a product of those two factors. And that's divided by square root of 3 times the square root of 3. It's the same thing as the square root of 9, which is plain old 3. So now, that's our final answer. 2 square root of 3 divided by 3. Because we now have a rational number in the denominator. It's no longer irrational as it started. Now, this little second example here, we need to separate this because the entire fraction is underneath the radical. So we're going to rewrite that as the square root of 2 divided by the square root of 3. And we're right back to the same problem. We have a radical in the denominator. We're not really concerned about the numerator, but we need to make this radical in the denominator a rational number. And to do that, we're going to multiply by the square root of 3 over the square root of 3. And multiplying these two radicals up here in the numerator, square root of 2 times the square root of 3, we can multiply those two together. Both of those are radicals. So that gives us the square root of 6. And then the square root of 3 times square root of 3 is the square root of 9, which is indeed just 3. Now, can you reduce this? The square root of 6 divided by 3? No. And the reason you cannot is because one of these is an irrational number and the other one is rational. Okay, if they were both irrational, then you could divide. Or if they were both rational, you could divide. But not one being the square root and the other not. So this is our final answer. That's our simplified answer for that. And then you had a few problems where you had to simplify the square root of a radicand that might have had perfect square factors. Now, by perfect square factors, I mean things like 1 squared, which is 1, 2 squared is 2, 2 squared is 4, excuse me, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on. So I want to find a factor in that 150 that is a perfect square. And as I was going through listing those, one of them that we listed here was 25. So I'm going to rewrite the square root of 50 as, let's see if I can extend that, the square root of 25 times 6. And then I can take the square root of the 25. The square root of 25 is just plain old 5. So that comes outside the radical. And what we have left underneath the radical is the square root of, we have 6 left there. So that's our final answer. And we can't simplify that anymore because 6 just factors as 2 times 3, and neither one of those are perfect squares. I hope this helps to just jog your memory.